All right, good morning everybody, and thank you for spending part of your day with us. I want to make sure that you are here to attend the Analysis Service Multidimensional versus Tabular. It is not necessarily a competition, but it is something that you want to consider. You can use both technologies, but if you are going to need to make a decision one over the other, we're going to look at a few high-level things that hopefully will help you and assist you with that decision. So a little bit about myself. I am a senior BI consultant with PragmaticWorks. I do some regular speaking engagements with SQL Saturdays, code camps, pre-cons, and within the past community. I am an active member of the Arizona SQL Server Users Group East Side. We now have 2 user group media groups in the Phoenix area. And I'm also an Analysis Services Maestro. I've been through the training back when they had that program at Microsoft. And right now, I also have my Twitter handle is Falcon Technic. I do have a LinkedIn profile. I have a blog. It's falcontechsolutioncentral.com, and the email address is there below at the Faulkner@pragmaticworks.com. Okay. So in this session, we are simply going to look to be covering 5 main considerations. Obviously, there could be more consideration you should take when you're making this decision for your organization, but those could differ depending on your organization, team, and other factors. But the 5 big ones as we are going to discuss today are scalability. Basically, how much data are we talking about? How much data are we trying to bring into our model? This is one of those things that you have to consider when you're talking about a multidimensional versus a tabular solution. You also have to look kind of down the road. Are we looking at, how much data in 6 months, a year, 2 years from now will we be continually bringing in our model? The next one is performance. While you can achieve blazing fast performance with both technologies, there are some potential differences here that we need to be aware of, and we'll talk a little bit about that. The time to develop. This may present a huge factor in your decision, so it's definitely important to talk about that. It's how much time do we have to get this solution live. Complex business problems. This typically has to do with what data relationships we're dealing with, what requirements are we going to be needing to implement within our tabular or multidimensional solution, and depending on what those requirements are, may drive us to one technology over the other. That you may be able to determine that based on the requirements. If you've already know some of the requirements up front, is certainly better served in one modeling experience over the other. And the learning curve is, this is one of the bigger ones that we want to talk about. What type of resources do we already have on our team? What are the resources that we're familiar with? Are we familiar with more of the multidimensional world versus the tabular world? And what type of learning or ramp up is it going to be required to implement a tabular versus multidimensional solution? So one of the things that I like to talk about here is in comparison and contrast of analysis services multidimensional versus a tabular. Is it important to understand that there are different flavors of analytic capability. So with starters, Power Pivot, you can create your own data models from various data sources, modeled and structured precisely to fit your needs. I typically like to use Power Pivot for a quick and dirty modeling tool because I can quickly do modeling with minimal data and determine if a model or a solution is going to work or if a certain structure is going to work. Then we have the Power Pivot for SharePoint, which is SharePoint 2013 and Excel services to add server-side processing and collaboration and document management. It does have a support for Power Pivot workbooks that you can publish to SharePoint. And as most of us are aware, the analysis services tabular are in-memory databases in analysis services, and they use compression algorithms and multi-threaded query processing using the Velocity in-memory analytics agent, or called VertiPack, and it delivers very fast access to tabular model objects and data by reporting client applications such as Excel or Power View. Basically, tabular models support data access through 2 modes, cached and direct query. More often than not, you will be using the cache mode, but you can integrate direct query, which will go out and grab data directly from your relational source. Cache mode will allow you to bring in data from multiple data sources. Then multidimensional uses cube structures for analyzing business data across multiple dimensions. And multidimensional mode is the default server mode of analysis services. It includes a query and calculation engine for all that data, and it has 3 different storage modes for balance and performance with scalable data requirements. And then just real quick, starting with SQL Server 2012, one of the things we didn't ask is what versions of SQL you're on, but starting with SQL Server 2012, an installation of analysis services can be done in either multidimensional or tabular or Power Pivot for SharePoint mode. Each of these deployments modes uses a different engine. Each analysis deployment mode supports different set of data sources, development management tools, query, and languages, etc. So basically the purpose of this slide is starting out on the left-hand side and moving to those solutions. The scalability goes up as well as the learning curve goes up as we move to the right. Now with SQL Server 2012, an installation analysis services, as we mentioned, can be done in either multidimensional or tabular, and it uses a different engine for each one, and each analysis service supports a different set of data sources, development management tools, and query language. This table is basically outlining some of the details of this, and during the installation of analysis services on the setup role page of the SQL Server setup, you need to select the SQL Server feature installation option for either multidimensional and data mining or tabular mode or Power Pivot for SharePoint option. Once you're done with the installation of analysis services, you cannot change the deployment mode of the existing analysis services instance. So whether you choose a multidimensional or tabular model, it is important to note that you can use client tools that generate either MDX or DAX to query the model. Excel and SQL Server reporting services are examples of the client tools that generate queries using MDX, and Power View is an example of a client tool that generates queries using DAX. There are 2 exceptions to this guidance. Power View is an interactive data exploration and visualization tool that is featured of the SQL Server 2012 reporting services add-in for Microsoft SharePoint 2010 and 2013 Enterprise Edition. If you want to use Power View or any other analysis client that uses DAX to query a BISM model, you need to use a tabular model. I believe future versions of SQL Server are expected to provide the ability to use DAX to query multidimensional models so that they can be accessed by a client like a Power View. Tabular models that have been configured to use direct query require a client tool that generates DAX queries such as Power View. Again, that is one of the key requirements if you end up going with direct query mode. I'm not sure if 2016 has resolved this, but there were plans with SQL Server later releases to potentially resolve that restriction. One of the things that we want to talk about is, before we start really diving into the details, is this BISM model primer. This has been kind of one of those things that Microsoft has talked about since basically the release of SQL 2012. And this is going to basically talk about, it is basically the BI platform where the BISM is a single unified BI platform which has both multidimensional as well as tabular data modeling capabilities to offer both of best worlds and a choice for the developer. The model based on BISM can integrate data from very different data sources, including traditional data sources like relational databases, line of business applications, or untraditional data sources like data feeds, text files, Excel, cloud services, and users can work with the data stored in the model in all these ways, regardless of how the model, whether it's a multidimensional or tabular, was developed. Having said that, the BI semantic model is one model that empowers all end-user experience and can be accessed in an intuitive way of using reporting services, Power View, Power Pivot, Excel, SharePoint, etc. Basically, any model that is based on the BISM, it can be conceptually divided into 3 layers. We have the data model, the business logic and queries, and data access. The data model layer is a BI semantic model. Developers can choose between multidimensional or tabular and projects based on the needs of their application. The multidimensional allows traditional ways of creating a multidimensional model. It allows creating a model with a cube and dimensions normally based on dimensional data. typically a model or star or snowflake schemas of a relational data warehouse. The tabular allows creating a model based on relational data sources and makes the development much easier, as it is easier to understand and does not require a star schema or a multidimensional layer. The business logic and queries is where the basically the logic sets within a multidimensional. This is where MDX comes into play, and this is, MDX has been around for a long time. It's one of the industry standards for multidimensional business logic and calculations and queries for OLAP cubes. And DAX, data analysis expression, is an expression language based on Excel formulas. So if you understand how to read or comprehend Excel formulas, DAX for the most part becomes pretty easier. There are a little bit more complex things that you can do with DAX, but DAX can be used to support model development, like creating calculated columns, measures, and KPIs for tabular models and power pivot models. Relationship navigation, context, and time intelligence also is supported within that. Then the data access layer, we are basically talking about what types of storage is available to us. So within the cached data mode, retrieves data from all the data sources stored in a compressed data structure that is optimized for high-speed data access. MOLAP is the storage format that has been used in analysis services cube or multidimensionals for a long time, for many releases of analysis services. Pass-through is a mode that pushes query processing and business logic down to the underlying data sources, thereby exploiting the capabilities of the source system and avoiding the need to copy data as a part of the model. ROLAP is complementary to MOLAP of multidimensional models, whereas direct query is complementary to the vertipack of the tabular data model. Both attempt to push query evaluation as much as possible down into the underlying data sources. Typically, ROLAP is optimized for large fact tables and relatively small dimension tables, star schema-like, while direct query is mostly neutral towards the back-end database structure through SQL Server. Direct query is supported only for models that are based on a single SQL Server relational data source. So the next area we want to talk about here is the scalability. And when we're talking about this, we're basically looking at the amount of data, the server resources, and the disk space. And typically on the amount of data, this is really important to understand not only how much data we're bringing in today, but what volume of data we'll be bringing into the model in the future as well. So a way to analyze this after your initial import, you may want to ask yourself some additional questions, such as how often will I be refreshing the data, what is the growth of that data, and how many rows are being added per day. The system I'm working off, is there a possibility that the system will be expanding in the next 6 months to a year? The key here is to think a little bit down the road and not just what is happening currently. Server resources, what are the processor capabilities? This is a good, typically when you're talking about a tabular and a multidimensional solution, you want to look at that as well as how much RAM. This is really the emphasis here is because tabular is in memory. Both use a lot of memory, but what you're looking at here is as far as tabular, if you're doing hardware sizing around a tabular solution, the areas that you really want to look at are the amount or bandwidth and speed of memory, fast CPUs, and the onboard cache size. If you're looking more towards the multidimensional side of it, it really depends on what you're doing with the cubes. So analysis services needs more memory and processes resources in the following cases. When processing large complex cubes, when the number of cubes within a single database increases, when the number of databases when a single instance of analysis services increases, when the number of analysis services on a single computer increases, and when the number of users who are accessing analysis services simultaneously. So concurrent, if you have a lot of concurrent people accessing your cube, typically this is a multi-dimensional solution, and you need to look at processor, very, very high-end memory and processor capabilities. So from a terms of scalability, and as we saw that in our flavors of analysis slide, the edge from a scalability perspective goes to MOLAP for pure amount of data that can be stored and processed. This will likely change as hardware becomes cheaper and cheaper. So as we've talked about, is within a multidimensional, most of it is pre-aggregated data from disk versus the in-memory technology, which is the X velocity. So the entire database is loaded into memory. Multidimensional, both can store very large amounts of data. Basically the restriction here is multidimensional is how much disk space do you have versus how much memory you have on the system. Multidimensional models use aggregations to increase query performance. Really, there are no aggregations within a tabular model as it's column-based storage. And on the multidimensional side, you get a 3-time compression typically, and a data compression of 10 times on a tabular solution. I've seen it up to 100 times, depending on some of the things that you can do. But as we want to talk about here, really scalability, if we were talking multidimensional versus tabular, I would submit that the edge really goes to the MOLAT technology. So one of the things that's key to understanding performance either in the multidimensional or tabular world is how does each engine or how does each internals of these technology process a query. So when we talk about a multidimensional solution, the MDX query comes in and is received by the query parser. The query parser has an XML listener which accepts the request, parses the request, and then passes it along to the query processor for query execution. When we get to the query processor, upon receiving the validated and parsed query from the query parser, the query parser prepares an execution plan, much like SQL Server. When you write a T-SQL, it generates an execution plan. And this plan dictates how the requested results will be provided from the cube data and the calculations used. The query processor then caches the calculation results in the formula engine cache. Then the storage engine responds to the subcube data. A request generated from the query process. It first checks to see if the requested subcube data is already available in the storage engine cache. If it is there, it serves it from there. If not, it checks if the aggregations are already available in the request. If yes, then it takes the aggregations from the aggregation store and caches it to the storage engine. Query processor for serving the request. If not, then it grabs the detailed data, calculates the required aggregations, caches it to the storage engine, and then sends it to the query processor. So as we come down to the bottom here, what we're basically talking about is what sets on disk. So if we come through here and none of our resorts are cached here, this is where it starts reading from disk and trying to bring this. Once we get to this level, the UDM model is less performant. So if you've ever heard of techniques such as cache warming techniques, this is one of the things that if you run queries that typical queries of your cube, this will warm this cache. So a lot of your queries would be served from here would actually make it quicker versus it having it served from disk down here. On the flip side of this, when we're talking about the tabular query processing, tabular models can be queried by using both MDX and DAX queries. This diagram explains the underlying query processing architecture analysis services when it is running in tabular mode. DAX queries can reference DAX calculations. These DAX calculations can reside in the model, in the session, or in the defined clause of the DAX query. Power BI reports, for example, generate DAX queries to gather the data they visualize. MDX queries can reference MDX calculations, either in the session scope or in the with clause of the MDX query. The MDX calculations can also reference DAX calculations, but the reverse is not true. MDX queries can directly refer to DAX calculations embedded in the model, and an MDX statement can also define new DAX calculations on the session scope or in with clause of the MDX query. So basically, when we're talking more about this, MDX queries against the tabular models are not translated into DAX queries. MDX queries are resolved natively by the MDX formula engine, which can call into the DAX formula engine to resolve the DAX measures. The reason this is important between these two storage engines is when you're troubleshooting a problem, it's really good to understand what kind of activity occurs in both the tabular engine and the multidimensional engine. ultimately, if you end up with a poorly performing query, either on a processing or a MDX query trying to return data sets, you're going to have to understand some of the query processing engine's capabilities between tabular and the multidimensional models. All right. So comparing the multidimensional versus storage engines, it is helpful to compare the data storage and retrieval in the multidimensional models versus the tabular models. Multidimensional models use row-based storage, which is read from disk as needed in queries, as we talked about in our storage engine review of the multidimensional. On wide fact tables, all measures in the fact table are retrieved from storage, even if only one measure is needed in a query. Models with hundreds of billions of fact rows are possible with a multidimensional model. Tabular models use columnar storage, which is already loaded into memory when needed by a query. During query execution, only the columns needed in a query are scanned. The Vertipack engine underlying the tabular model achieves high levels of compression, allowing the complete set of model data to be stored in memory, and it achieves very fast data scan rates in memory, providing great query performance. And tests have shown that, like for example, on a commodity laptop, hardware can service Vertipack scans up at 5 billion rows per second, or more can store in memory in billions of rows. On a commodity server, hardware tests have shown that Vertipack scan rates of 20 billion rows per second or more, with the ability to store tens of billions of rows in memory. To really contrast these technologies, try loading a typical 2 billion row fact table into both a multidimensional model and a tabular model, and a simple aggregation query performance test would show results in the following order of magnitude. If you notice, the multidimensional model query performance on large models is highly dependent on whether the administrator or the developer has anticipated query patterns and built aggregations that are in line with the queries that are being issued against the multidimensional. In contrast, the tabular model query performance requires no aggregations built during processing time in order to achieve great query performance. Of course, not every query is going to achieve such optimal performance, and to work towards determining the bottleneck for poorly performing queries and applying the appropriate fixes is entirely another presentation, which I'm currently working on to diagnose this. But what we're basically looking at here is, if I went through this scenario and on the UDM solution, if query hits the aggregations appropriately, the result sets could be returned in seconds, or in some cases maybe even sub-second, millisecond time frame. If the query misses aggregations but the fact data is cached in memory, we're maybe looking at in the minute range or minutes. If the query misses aggregations, no fact data is cached in memory, and the file system cache, this means it's coming down to the disk and having to read it from disk. You could be looking at minutes in terms of magnitudes. Tabular, always from a performance standpoint, is probably going to perform a little bit better. So what we want to talk about here is just comparing and contrasting this. I would say from a performance standpoint that the edge goes to tabular models. Again, as generally speaking, a tabular model will perform better. As we have talked about, the pre-aggregated, if it's pulling it from disk on the multidimensional side, you're going to experience long running queries. And one of the things that's very key about tabular, and I'll demonstrate this, is it's very good at returning lower granularity of data. So if you did that within a multidimensional solution, you will just see your query basically clock or spin. And we will be coming up on a demo here where I'm going to actually demonstrate this. So what we are looking at here, if you can see this on the screen, what I am essentially doing is a XML query, and I'm clearing the cache of the UDM model, and then also I am going to as well clear the cache on a tabular model. So in order for me to do this, all I'm going to do is execute this XML query and return successful. And now I am going to actually clear the cache of my multidimensional model. And this takes a little bit longer. And next, what I want to do is to just demonstrate this. I'm actually going to create a SQL Server profiler trace on my tabular solution first. I'm going to connect this. I'm going to do my tabular, and I want to save it to a table, and we'll say yes, connect there, and I've already got this ready to go, and I want to move this to a tabular profile, and it'll actually say, do you really want to do that? And now what I'm doing is I'm launching a profiler based on a tabular experience. And what I have here is I have a Excel sheet or an Excel workbook connected to my tabular model. And what I am going to demonstrate here is actually I want to bring in a couple of measures here. I'm going to bring in a single measure, my internet total sales. Then I want to start by increasing this, or actually increasing the data that is running into my profiler. I am going to bring in over my state province name, my city, and one more to kind of show a little bit more of a detailed look, more fields. I want to bring over my product name, and you actually see that that ran fairly quickly. So I brought in quite a bit of detailed data. I want to basically collapse this. Now what we will see is I switch back over to my trace. I've captured this data on the trace, and what we will be looking at here after we perform our multidimensional trace is we will be summing up the time it took for these query end events. So anything that you see between this from here to here is a query execution. And we will go ahead and stop that one, and I want to clear that one. And next, I want to run back out and now do the same thing. I want to run a profiler for my multidimensional analysis services. I want to connect there, MD, and I want to save those results to a table. I'm going to connect, and same database. And the table I am actually going to put it out to is my multidimensional trace. Run that. I'm going to start firing this, and I just want to make certain that my cache is definitely clear, so I'm going to actually do this one more time because this is important to demonstrate this. Execute that. We're good. Now I am actually going to do the same basic test using my multidimensional. So I'm going to bring over a measure from my internet sales measure group. I will also now bring over several items from several different dimensions. From my geography dimension, I'm bringing over my state province, my city, and now I want to bring over from my product dimension essentially the same detail that I was wanting before. And what you will notice is watch how this starts to spin and cycle. The other piece that is interesting here is to, some of the things that we're seeing as far as the CPU, the memory. You're starting to see some of these things churn up. And as this thing churns, we're going to keep watching this information, and we can see that it's really hitting the CPU. We're going to see that the memory is getting clocked pretty good. We don't necessarily have a tons of activity on our disk except for our primary, which this is where this is running. But you can see that this is actually taking a lot more resources to resolve when we're looking at a more granular level detail. And once we get this finished, what we will actually do is we will show you the difference between the time it took between the tabular solution to render essentially the same query and the multidimensional. And as you can see, this multidimensional using this kind of more granular level detail is actually starting, still running. This query is still running. We're still processing. The memory is still escalating. The CPU is at about 60% or so. And we're seeing some activity on our disk. But once this resolves, I will switch over to my Management Studio to show you the results of how long each query took. And now we're reading the items, and now it should be just about ready to return the results. And here we go. So at some point, there we go. So we now have just resolved, and you saw how long from a multidimensional area that actually took. So the thing I want to just show here is that I'm doing these various traces, and my first query here is going to return the results from my tabular. The query here is going to actually return the results from my multidimensionals. Let me jump back over here and run these queries. Yeah. Time. All right, here we go. So what we are looking at here is that after we cleared the cache, it took 618 milliseconds from the tabular to return the index query that was issued. On our multidimensional side of things, it took over 86,000 milliseconds, or 86 seconds, to return the query results based on the test we just did. So this again underscores why I would say that a tabular model generally is more performant than a multidimensional one. But there are a number of ways that you can make a multidimensional model more performant through aggregations, partitioning, cache warming, those techniques. There are many techniques out there that you can leverage to make your multidimensional models more performant. So when we're talking about time to development, this is really quick. I would say the edge goes to tabular, simply meaning that it takes far less time to develop. You can upgrade from Power Pivot. So let's say you create your model in Power Pivot, and you say, oh, you know what, it's going to be better that we now start designing this in a tabular solution. I can import my Power Pivot solution into a tabular model. The tabular model does not require a lot of multidimensional or dimensional modeling exercises. However, I prefer to do it against a dimensional model because it does perform a little bit better, but it's not required. It's much simpler to create an interface when creating the model. Typically, the multidimensional takes a longer time of development cycle, so you're going to really have to understand how you need to model your data up front, and there is no upgrade path, so you can't create a Power Pivot model and import it into multidimensional, and it does require a dimensional model, star schema, snowflake, that type of solution. So data model and data relationships, I think this is probably where a lot of consideration has to be looked at. The characteristics of your data model are really the core consideration choice of modeling experience. A fundamental requirement of any data model is correctly representing how the data elements within a data model interrelate and connect, much like the pieces of a jigsaw puzzle. Both tabular models and multidimensional models require you to define relationships among your source data tables. Common relationships that you'll see in data modeling are one-to-many, many-to-many, and reference relationships. So really the key thing to start thinking about when you are considering either technology is that you need to understand how the data relates to one another, or how am I going to relate the data. Quick story on this, I worked recently on a project where I did not actually create the data warehouse or any of the underlying structures. I was just provided a view that had about 300 columns, and they said, you need to figure out how this data relates to each other. So I had to get very creative in how I broke up that data from a 300 column view to multiple views to see how that data related. And that was really the key to making it successful. Instead of bringing over one ginormous view, I broke up the views into more logical representations of the data with dimensions and facts. And the key to that was understanding how that data related. And that was actually it initially started out as a Power Pivot solution, and then we ultimately moved it to a tabular solution because of the amount of data we were bringing in. So when we talk about data relationships from one-to-many, both the multidimensional modeling experience and the tabular modeling experience support one-to-many relationships. So if you think about a typical fact and dimension relationships, that's what I mean by a one-to-many relationship. We have unique records in our dimension table. We potentially have the same customer repeated multiple times in our fact table, so like, for example, an internet sales table. So that's what we mean when we say one-to-many. Next, we want to also look at data relationships in many-to-many. Now, this can be a very interesting from a tabular modeling experience. Can many-to-many be done? Yes, it can be done in tabular modeling. However, it requires some pretty fancy DAX from time to time, depending on what you're trying to do. Multidimensional modeling, it is natively supported. So if you find yourself, we're talking about data relationships, business requirements, if you find yourself in a situation where you're having more than just one or two many-to-many relationships, you're probably going to need to consider a multidimensional solution, or you need to figure out a different way to put that data at a different granularity that your model could potentially support. Again, just out of the box, multidimensional does support it. Tabular modeling does support it, but you have to be pretty creative with DAX. There are several things out there. Marco Russo has some articles out there regarding this, but on that same project that I was just speaking of, they ended up coming in and saying, well, we need a many-to-many. We ended up with about 3 or 4 starting to develop, and I suggested to them that maybe in the long term we needed to be looking at a multidimensional modeling solution versus a tabular modeling if we could not break out those dimensions and fact tables at a more granular level. So reference relationships were supported in tabular modeling and also supported in multidimensional modeling. So a data model may contain a set of common attributes that are related to multiple entities. For example, geographic attributes are related to customers, suppliers, and stores. In a multidimensional model, you must create a dimension containing the common attributes and then create reference dimension relationships to each of the related modeling. In a tabular model, there is no need to create reference relationships. In a tabular model, all you need to do is create a relationship between the table containing the common attributes and a table containing the related entities. Okay, data relationships and hierarchies. Standard hierarchies, both are supported in both technologies. Ragged hierarchies, supported in multidimensional, not supported in tabular. Well, we'll talk about that later. Parent-child, supported natively in multidimensional. It is supported in tabular, but you have to use some DAX and specific functions within DAX. We'll take a peek at that in our next demo. But really, hierarchies are really used to categorize data into tree structures to facilitate drill downs for analysis. And basically, standard hierarchies are composed of ordered levels that come from columns in your source data. For example, one of the easiest ones to understand is a date hierarchy: year, quarter, month, date, for example. That is what we talk about when we're talking about standard hierarchies. And ragged hierarchies are typically hierarchies that occur when a given data element is missing in the hierarchy tree. So you may have in a one of the key ones I've actually worked on is a GL. I had to create a hierarchy in a GL, and depending on what level you were at, not all levels were equal. I didn't necessarily have equal levels across each level within the hierarchy, so we were actually doing that within a multidimensional. Ragged hierarchies are not really easily done within tabular, or actually not done. Parent-child hierarchies offer more complicated kind of hierarchical design. One of the examples of that would be like an organizational structure, like from CEO down to your EVPs, et cetera, et cetera, et cetera. You can move down. You can also have ragged hierarchies in that, depending on the number of people that report to a certain level. And basically, this kind of hierarchy is modeled by creating a relationship between two columns in a source data table, a parent and a child type. A parent key and a child key, for example. Multidimensional out of the box provides this. Tabular models can provide this if you leverage using DAX. All right, so additional modeling features, perspectives are supported in multidimensional tabular modeling. They are supported. Translations, not supported in multidimensional, not supported in tabular. Actions, like drill-through actions, supported multidimensional, not in tabular. However, I believe there is a tool out in CodePlex that will allow you to do this in tabular modeling, using BIDS helper, I believe. Drill-through is available on multidimensional and tabular. Write back, if you had to write back to a dimension, is supported in multidimensional, not supported in the tabular modeling experience. So when it comes to complex business problems, if you have built-in complex relationships, like we've got to have like role-playing dimensions, where I'll give you an example of that. Role-playing is if I have several different date type dimensions in my solution. I can use one date table in my multidimensional solution and reference that date table over and over and over. In tabular, at least in its current state, you would have to potentially bring in that date table multiple times to have multiple date dimension capabilities. Parent-child is natively supported in multidimensional, not natively, but can be done through DAX. Many relationships, again, native to multidimensional, can be accomplished using DAX. So let me jump over here real quick. Coming to Hey Liz, can you still hear me?
Yes.
Okay, sorry. I accidentally hit the button on my Jabber speaker. Sorry about that, guys. So one of the things that I want to show here is a quick demo of how you would accomplish a parent-child relationship within a DAX solution, or in a Power Pivot solution, which you could potentially port over to a tabular solution. What I have here is a very basic Power Pivot solution. What we're looking at here is the Power Pivot side of this. So I'm looking at my actual data diagram, and I want to look at the data diagram. And what I basically wanted to show here is that within Power Pivot, you have to use these functions that will allow you to create these functions, create this, essentially this parent-child hierarchy that we're trying to do. And the path item function basically returns items specified at the specified position from a string, resulting in an evaluation path. So in this case, what I did is I wanted to do path item path 1, and what it does is it's using this, I don't know if you guys can actually see this, but it's using this pipe delimiter here to determine whether it's in the first position, second position, or third position. And in this case, my level 1 is Bill, so everything in front of that pipe would be my level 1. And then this, I use the path item, path 1, to return that value. Then I use path 2 to return Catherine at my next level. And then here I also use that path function to use 3, that it returns Chris. Now, as I've done that, on my diagram view, I create this simple hierarchy: level 1, level 2, level 3. That allows me that hierarchy. Now I actually can come back to this and take a look at what that looks like from this point of view. So once I've basically navigated this, you can see that kind of parent-child relationship within this. Now, you can see here that there's blanks here. This would be because there's nothing reporting to it. A little bit more complex version of the DAX would allow you to eliminate this, but like for example, Bill has 3 levels underneath him, so these are rolling up. So this is what we are showing here. that this can actually be accomplished using DAX to provide that parent-child relationship type look to navigating the data. All right. So when we talk about a learning curve, as we looked at earlier on that, different flavors of analysis, we are talking about learning curve. I would say the edge goes to tabular simply because it's a little bit easier to create your model, and a lot of it's drag and drop. The relationships are typically very simple. You don't have to use composite key relationships as you may have to sometimes in multidimensional to avoid your attribute key errors. Those are types of things that you do in tabular that are available to you in tabular that takes a lot of extra work within a multidimensional. You know, when you're doing multidimensional, you're dealing with MDX both from an expression and query language perspective. I would say it's difficult to learn, but it's not impossible to learn. If you apply yourself, you can learn MDX. It is much beneficial to navigating hierarchies. It is a little bit more complex when you want to do KPI creation, and it does foster multiple relationship types that can sometimes be tricky to make sure that you've got them set up. So again, I believe the edge goes to tabular from a learning curve perspective. All right, business logic. Business logic can add tremendous value to any data model in the form of calculations and business rules, then enhance the analysis for end-user analysis. Again, all of this here is essentially what to talk about from a multidimensional and tabular. I would say the row-level transformations, it's a lot easier from a tabular model. The row-level transformation created using calculated columns, which if you understand Excel-based formula language, you're able to do that much easier. Again, I believe from a business logic implementation, edge goes to tabular. From an aggregated values, measures can be used to aggregate. You can be aggregated bottom to top across all hierarchies. And from a tabular perspective, measures are used to aggregate values. You don't have to create additional aggregations to have that done. Aggregates are calculated query time. And you can also include calculation based on multiple aggregated columns. Business logic and calculations, use MDX to create calculations on the multidimensional side. DAX are used in the tabular. The difference between how you get, say, down to a finer subcube level of each one in the multidimensional world, you would use a scope function versus a filter function in tabular. You can actually use DAX to dynamically evaluate formulas depending on filtering context, and you can apply scope assignments for multiple calculated measures in a multidimensional world. This one here, you can basically, this is very close here in terms of these business logic scenarios. Again, with the hierarchy logic, that's actually DAX provides functions to work with data organized into a hierarchy actually in tabular models with that create MDX on the other side. So again, this comes back to what's your preference for learning in those scenarios. So as I would say, business logic, it tends to be a favor the MOLAP solution or modeling experience a little bit, but I would say definitely would want to explore your tabular side. If you haven't made a decision on one or the other, start with tabular. It's easy to get that going and get a model created quickly. Multidimensional actually takes a little bit longer to create. Security, again, you can apply security to both models, and really there are subtle differences in the capabilities which are important to understand, but really I think from a security standpoint, the edge goes to a MOLAP scenario. So you could actually manage the security down to a row level. in a multidimensional solution or cell level, and it's a lot less secure from a tabular. It's a lot harder to secure a tabular model. Both support dynamic security. You would have to use MDX on the multidimensional side and DAX on the tabular side. You can do, as I said, cell level security on multidimensional, but you cannot do cell level security on a tabular model. Okay. So in summary, you want to consider tabular if you have a shortened development timeline. If you're working with a plethora of memory, memory is not an issue. Your data model is simple. I would say if you've got like a one-to-many kind of a star schema and it's simple or it's very easy to determine the relationships, tabular may be a very good choice. If you have many disparate data sources coming in, if you have something from Oracle, you have something coming from the web, you have something coming from SQL. If users need to query large amounts of detail level data, those are good candidates for tabular or good reasons to consider tabular. One other one I should list there, if you don't have a tabular or multidimensional solution, start with a tabular solution. That's getting you off the ground and get you going. Just remember that you're not going to be able to port the tabular solution over to multidimensional. On the multidimensional side, if you're using SQL 2008 R2 or earlier, simply because tabular was not available in 2008 R2. If you have multi-terabyte data sources, if you have a complex data model, if you have many-to-many or several many-to-many relationships that you need to resolve, that's one example. If you need multidimensional only features such as actions, data mining, write-back, translations, this is when you want to consider a multidimensional solution. One final real quick item that I want to cover is this decision matrix, and this was actually leveraged from one of our colleagues, a colleague I work with here at Pragmatic Works. And what this decision matrix allows you to do is if you enter some values in here based on what the importance is to you, it could actually outline or give you kind of a score based on what your needs may be. And in this case, looking at some of the things I was looking at from what we covered in our presentation today, that based on that, my tabular solution was kind of the winner in this case, but because the tabular multidimensional solutions were fairly close, I may look at both. But based on this score, I would probably go with starting with a tabular. Then I have actually expanded this quite a bit and looking at a attribute by attribute type thing. So if I wanted to get a lot more granular in my analysis, I could do something such as this. And again, based on my evaluation, this came back as my tabular solution being the winner, and so I'm probably going to start with a tabular solution. So I use some of these resources. You can probably go out and Google these types of things to understand a lot more than we were able to cover in an hour. But these were some of the resources that I used, and I hope that this session answered some of your questions, provided you some guidance. I want to thank everybody for spending some of the time with me today. And Liz, that is the end of my presentation. If we want to do questions or whatever it is that we need to do, that would be appropriate now.
Yeah, actually you have access to all the questions because there are a lot of them, so I figured it would be easier for you.
Okay.
Pull them up and just go through the ones. Some of them might be similar, but the ones that you think you should highlight, and then.
Okay, I'm trying to get there. Okay, there are a bunch.
Yes.
Again, if I do not get to your question, what I will commit to doing, hopefully, Liz, we can get a copy of those questions.
Absolutely.
I'm trying to.
And also, real quick, while Alan's accessing the questions, I know a lot of you always ask about PowerPoints and things like that. In your GoToWebinar control panel, there is a handout section, and his PowerPoint is in that section. So feel free to go ahead and download that while he's pulling up all the questions.
It looks like, and I am trying to see the person's name. The first question is, I believe, what if we use both? I believe we're talking about if we use both modeling techniques. Hey, there is nothing wrong with using both if your environment supports it. One of the ways that we've leveraged both modeling experiences and projects I've been working on is that, for example, we had a finance group that had tons more data than some of the other smaller business units. So what we did is we developed a multidimensional solution to support the analytic needs of our financial group, and then we leveraged the tabular solution to provide that tabular experience for some of the smaller data sets for some of the smaller business units. So there is nothing wrong with using both, but it's just kind of an example of how I've worked with it in a project setting. Let's see. I have data which contains 250 million rows. I am right now using multidimensional. Can tabular, it's hard to read that one. Can tabular handle it? Your tabular can handle it if your memory on that system can store it all in memory. And I'm working on a blog post that talks about hardware sizing from a multidimensional versus a tabular perspective. So I'll be looking at for that. But the only real restriction from a tabular perspective is can that database fit into memory? If fit into memory and fit into memory comfortably. If so, tabular can work. Also, as we outlined, if your model is simple and you don't have lots of many-to-many relationship type stuff or very complex relationships, yes, tabular can work. Again, that's another scenario where multidimensional or tabular could work, but you would have to understand the limitations of each technology to understand that. Another consideration is user interface options. Absolutely. That is a very key consideration, because if you've got people accustomed to interacting with cubes using Excel, and because they're already familiar with that and comfortable with that, doing other things in their normal workday situations, Excel can be a very good tool to interact with cubes, either in tabular or multidimensional. There is no restriction there. One of the things you have to start understanding restrictions about what types of queries are being issued by the tool. So as we covered, if you're wanting to use PowerView, for example, that issues DAX queries, so that requires you to use a tabular model. A tabular model can resolve MDX queries because initially what happens, Excel issues and generates MDX queries, which then are translated by the DAX or the tabular engine that we covered a little bit earlier in the presentation. That's a great question, a great point. Thank you for that. Scaling, show multidimensional. Yes. Yeah, the graph showed multidimensional has better scalability. Yes, the multidimensional has better scalability from the amount of data that it can handle and the types of relationships that can be implemented out of the box. That is the two primary factors there. Okay. Yes, you can use Power BI to report off a cube. Can tabular, sorry, these are really hard to read. Can tabular model be used as input data source for data mining? Yes. You would actually have to use a multidimensional solution to do that. Quantify very large amounts versus large amounts of data. Now, I'm assuming that you're probably looking there for a number of rows. The largest cube I've actually worked on multidimensional was 3 terabytes in size. Our largest fact table was about 5 billion rows. So that's that gives you, if you're in the billions neighborhood, I call that very large. That's what I would call very large in terms of data. There's one here that says if you've got 10 billion rows, Which one would you use? I would recommend multidimensional. How about the putting a complex? I'm not sure if I follow the question. What? Well, complex calculations, both in the MDX and DAX world, are going to run a query time. The real key here is if you've got those aggregated in a multidimensional world properly, it will perform well. Again, as we talked about, generally speaking, tabular performs better when it comes to just straight up performance. Let's see. There's a comment here. Multidimensional doesn't require a dimensional model. I will just make this comment to you. If you approach putting a more normalized model in the multidimensional, you are definitely going to pay for the price on the processing side, because in almost all situations where you end up having very expensive return is the query and the number of joins that are performing the query. So if you are, say, putting basically a fact table together or dimensions together using lots of joins, you are going to take a big hit on the processing side. I wouldn't recommend it. It is well documented that star schemas actually perform better in a multidimensional world. Against the tabular model, fields from. Okay, that puts us a little over 10 o'clock. That's as many questions as I got to. So, Liz, I will turn it back over to you.
Okay, great. Well, like Alan said, I will send him all these questions, and we'll get them posted for the ones that didn't get answered. Again, if you didn't hear me before, his PowerPoint presentation is available in the GoToWebinar control panel under the section handouts for you to download. So if you would like that, please go ahead and download there. And as always, the session was recorded, so you'll receive an email tomorrow with the recording link if you'd like to pass it on or watch it again. If you guys have any questions, feel free to reach out to me, Liz. It's the email that comes with all your GoToWebinar information, and I'll be happy to pass along any information to Alan. Thanks again, everyone, for joining us today, and we hope to see you again soon.